Welcome to RenEnergy.com, your renewable energy and sustainability platform. At RenEnergy.com, we believe in the power of clean, sustainable energy to transform the way we live and work. That's why we offer a range of solutions for businesses and homeowners looking to switch to renewable energy sources such as solar, wind, and water. Welcome to an exciting exploration in the realm of renewable energy, where innovation meets sustainability, shaping our future. Today, we embark on an enlightening journey to uncover the advancements in a pivotal technology, the next generation of green hydrogen electrolyzers. As the world grapples with the urgent need for sustainable energy solutions, these innovative devices are not merely components, they are the driving force behind the green hydrogen revolution, redefining our approach to energy production. Green hydrogen, distinguished by its production from renewable energy sources, stands as a beacon of hope in our quest for a cleaner, sustainable future. It offers a versatile solution, with applications spanning from powering industries to fueling vehicles, all while emitting zero carbon. At the heart of this green hydrogen production lies the electrolyzer, a marvel of engineering that transforms water into hydrogen and oxygen through the process of electrolysis. But why is this significant? As we confront the challenges posed by climate change and the depletion of fossil fuels, the transition to renewable energy sources becomes imperative. Green hydrogen emerges as a key player in this transition, offering a sustainable and scalable alternative to fossil fuels. It holds the promise of decarbonizing sectors notoriously difficult to electrify, including heavy industry and long-haul transportation. The role of electrolyzers in this context cannot be overstated. These devices not only enable the production of green hydrogen, they are the gatekeepers of efficiency and cost-effectiveness in this process. As we delve deeper into the latest advancements in electrolyzer technology, we uncover how these innovations are making green hydrogen more accessible, efficient, and economically viable. Join us as we explore the cutting-edge developments in electrolyzer technology, understand their impact on the hydrogen economy, and envision a future powered by clean, sustainable energy. The journey towards a green hydrogen future is not just a technological endeavor, it's a collective march towards a sustainable world for generations to come. Basics of electrolyzer technology. Electrolyzers are at the forefront of green hydrogen production, serving as the critical link between renewable energy sources and the generation of hydrogen. Understanding the basics of electrolyzer technology is essential to appreciate the advancements in this field. An electrolyzer is a device that uses electrical energy to drive the chemical reaction of water electrolysis, splitting water into hydrogen and oxygen. This process is fundamental to producing green hydrogen, which is hydrogen generated from renewable sources like solar or wind power. There are three primary types of electrolyzers: Proton Exchange Membrane, PEM, Alkaline, and solid oxide. Each type operates on different principles and is suited to specific applications. PEM electrolyzers, known for their high-purity hydrogen output and dynamic response to changing power inputs, are ideal for integration with fluctuating renewable energy sources. Alkaline electrolyzers, the oldest and most mature technology, are characterized by their use of liquid electrolyte and are typically used in large-scale hydrogen production. Solid oxide electrolyzers, the newest type, operate at high temperatures and have the potential for high efficiency but are still in the early stages of commercialization. The choice of electrolyzer technology impacts not only the efficiency and cost of hydrogen production but also its scalability and integration with existing energy infrastructures. For instance, PEM electrolyzers' ability to rapidly adjust to varying power inputs makes them well suited for direct coupling with renewable energy sources, which are inherently intermittent. This capability is crucial for maximizing the use of renewable energy and minimizing waste. As we explore the next generation of green hydrogen electrolyzers, it's important to understand these foundational technologies and their evolution. Innovations in electrolyzer design are pushing the boundaries of efficiency, cost, and scalability, opening new avenues for the widespread adoption of green hydrogen. These advancements are not just incremental improvements but potential game changers in the race towards a sustainable energy future. Innovations in electrolyzer design. The realm of green hydrogen is witnessing a technological revolution, particularly in the design and functionality of electrolyzers. These advancements are pivotal in making green hydrogen a viable and scalable alternative to fossil fuels. The innovations in electrolyzer technology are diverse and multifaceted, addressing everything from efficiency and durability to cost-effectiveness and scalability. One of the most significant developments has been in the realm of materials science. Researchers are exploring novel catalysts and membrane materials that can operate more efficiently and withstand the harsh conditions of electrolysis. For instance, the development of non-precious metal catalysts in PEM electrolyzers aims to reduce costs without compromising efficiency. Similarly, advancements in solid oxide electrolyzers include the use of innovative ceramic materials that can operate at higher temperatures, thereby increasing the overall efficiency of the hydrogen production process. Another area of innovation is in the system design. The latest electrolyzers are being designed to be more modular and adaptable, allowing for scalability and easier integration with various renewable energy sources. This modularity is crucial for the deployment of electrolyzers in different environments and for meeting varying demand scales, from small local systems to large industrial applications. The integration of advanced control systems and software is also playing a crucial role. These systems allow for better management of the electrolysis process, optimizing energy use and adapting to fluctuating power inputs from renewable sources. This integration is critical for maximizing the efficiency and lifespan of electrolyzers, especially when coupled with intermittent energy sources like solar and wind. These innovations in electrolyzer technology are not just enhancing the performance but are also driving down the cost of green hydrogen production. As these technologies mature and scale up, we are moving closer to a reality where green hydrogen can compete with traditional energy sources. The impact of these advancements extends beyond hydrogen production. They are key enablers in the transition to a sustainable, zero-emission energy landscape. Efficiency breakthroughs in green hydrogen electrolyzer technology. Efficiency breakthroughs in electrolyzer technology are critical in advancing the viability of green hydrogen as a sustainable energy resource. These improvements are not just incremental, they represent a leap forward in the quest for a carbon-neutral future. Central to these advancements is the enhanced performance of electrolyzers, which directly translates to more efficient and cost-effective green hydrogen production. One key area of progress is in the optimization of energy consumption during electrolysis. Innovations in electrolyzer design, such as improved electrode materials and more efficient ion exchange membranes, have significantly increased the energy efficiency of the electrolysis process. These improvements mean that less electricity is required to produce the same amount of hydrogen, a crucial factor considering the energy input is one of the largest contributors to the cost of green hydrogen production. Another significant development is in the dynamic operation of electrolyzers, especially in response to the intermittent nature of renewable energy sources. Modern electrolyzers are being designed to operate more effectively under variable power inputs, such as those from solar or wind energy. This capability is vital for optimizing the use of renewable energy, reducing waste, and ensuring a more consistent hydrogen output. The push towards higher pressure electrolysis is another area of innovation. By operating at higher pressures, electrolyzers can produce hydrogen that is more suitable for storage and transport, reducing the need for additional compression steps and associated energy costs. This advancement not only improves the overall efficiency of the hydrogen production and supply chain but also helps in reducing the infrastructure costs. These efficiency breakthroughs are paving the way for green hydrogen to become a more economically viable and scalable alternative to fossil fuels. As electrolyzers become more efficient and less expensive to operate, the potential for green hydrogen to play a pivotal role in the global energy mix increases significantly. These advancements are not just technical achievements, they represent essential steps towards a sustainable energy economy, where green hydrogen can be produced, stored, and utilized efficiently and cost-effectively. Scaling up, challenges and solutions in green hydrogen electrolyzer technology. The scaling up of green hydrogen production using electrolyzers is a crucial step toward realizing a sustainable energy future. However, this process is not without its challenges, which span technological, economic, and infrastructural aspects. Addressing these challenges is essential for the successful integration of green hydrogen into the global energy mix. One major challenge is the high initial cost of electrolyzer systems. Despite recent advancements, the capital expenditure for electrolyzer installations remains significant, particularly for large-scale operations. To tackle this, continuous research and development are focused on reducing the cost of core components, such as electrodes and membranes, and optimizing the manufacturing processes. Economies of scale can also play a significant role as the market for green hydrogen expands, leading to reduced costs through mass production. Another challenge is the integration of electrolyzers with renewable energy sources. The intermittent nature of solar and wind power requires electrolyzers to be highly flexible and responsive to fluctuations in power supply. Innovations in electrolyzer design, including advanced control systems and modular configurations, are being developed to enhance their adaptability and efficiency in dynamically changing environments. This adaptability is key to ensuring a consistent and reliable hydrogen supply. Furthermore, the infrastructure for distributing and storing hydrogen presents its own set of challenges. Developing robust and extensive hydrogen distribution networks is crucial for the widespread adoption of green hydrogen. Innovations in hydrogen storage, such as high-pressure tanks, metal hydrides, and liquid organic hydrogen carriers, are being explored to improve the efficiency and safety of hydrogen transport and storage. Addressing these challenges requires a coordinated effort between researchers, industry players, and policymakers. Investments in research and development, supportive policies and incentives, and collaborations across sectors are vital for overcoming these barriers and scaling up green hydrogen production. As these efforts come to fruition, we move closer to a future where green hydrogen plays a central role in meeting global energy demands sustainably and efficiently. Case studies and current research in green hydrogen electrolyzer technology. Examining real-world applications and current research in green hydrogen electrolyzer technology provides valuable insights into the practical implementation and future potential of this field. Case studies and ongoing research projects not only demonstrate the feasibility of these technologies but also highlight the innovative approaches being undertaken to address challenges and optimize performance. One notable case study is the integration of large-scale electrolyzers with renewable energy farms. For instance, projects in Europe and Australia are pioneering the use of wind and solar energy to power electrolyzers for large-scale hydrogen production. These initiatives demonstrate the practical application of green hydrogen as a storage medium for renewable energy, showcasing its potential in balancing energy grids and providing a sustainable alternative to fossil fuels. In the realm of research, significant strides are being made in improving the efficiency and reducing the costs of electrolyzers. A prominent area of focus is the development of advanced materials for electrodes and membranes. Researchers are exploring new catalysts that can operate at lower voltages, thus reducing the overall energy consumption of the electrolysis process. Other studies are investigating the longevity and durability of these materials, aiming to extend the lifespan of electrolyzers and reduce maintenance costs. Another exciting area of research is the development of hybrid electrolyzer systems that can operate under varying conditions and integrate seamlessly with renewable energy sources. These systems are designed to be more adaptable and responsive to the fluctuating nature of solar and wind power, ensuring a more efficient and consistent hydrogen production. These case studies and research initiatives are not just proof of concept, they are tangible steps towards a scalable and economically viable green hydrogen industry. By highlighting these examples, we can illustrate the real-world impact of electrolyzer technology advancements and inspire further innovation in this field. The journey towards a sustainable energy future is being paved by these pioneering efforts, bringing the promise of green hydrogen closer to reality. Future outlook and potential of green hydrogen electrolyzer technology. As we look to the future, the potential of green hydrogen electrolyzer technology in transforming our energy landscape is immense. This technology is not just a component of the renewable energy sector, it's a catalyst for a broader shift towards a sustainable, zero-emission future. The advancements in electrolyzer technology are paving the way for green hydrogen to become a cornerstone of global energy strategies. The ongoing research and development in electrolyzer efficiency, cost reduction, and scalability are set to continue at an accelerated pace. The future may see electrolyzers that are not only more efficient and cost-effective but also more robust and adaptable to various operational environments. Innovations like artificial intelligence and machine learning integration for predictive maintenance and optimization are on the horizon, further enhancing the efficiency and reliability of electrolyzers. In terms of application, the future holds vast potential for green hydrogen. It's poised to play a critical role in sectors where direct electrification is challenging, such as heavy industry, long-haul transportation, and aviation. The use of green hydrogen in these sectors can significantly reduce carbon emissions, contributing to global climate goals. Additionally, the integration of green hydrogen in energy grids as a storage medium is a promising avenue. With its ability to store excess renewable energy and release it when needed, green hydrogen can help stabilize energy grids and ensure a consistent energy supply, further facilitating the transition away from fossil fuels. Policy and economic factors will also be crucial in shaping the future of green hydrogen. Supportive policies, incentives for green hydrogen production and use, and international cooperation can accelerate the adoption and implementation of electrolyzer technologies. As the economic viability of green hydrogen improves, we can expect increased investment and growth in the sector. The future outlook for green hydrogen electrolyzer technology is bright, filled with opportunities for innovation and growth. As this technology continues to evolve, it holds the promise of driving significant changes in our energy systems, moving us closer to a sustainable and carbon-neutral world. Conclusion. As we conclude our exploration of the next generation of green hydrogen electrolyzers, it's clear that we are standing at the cusp of a major energy transformation. The advancements in electrolyzer technology are not just incremental changes, they represent a significant leap forward in our pursuit of a sustainable and zero-emission future. From innovative materials and design to enhanced efficiency and integration with renewable energy sources, these developments are reshaping the landscape of green hydrogen production. The journey towards a sustainable energy future is both exciting and challenging. Green hydrogen, facilitated by advanced electrolyzer technology, holds immense potential in decarbonizing various sectors and providing a reliable, clean energy source. However, the path forward requires continued innovation, investment, and collaboration across industries, governments, and communities. Now, we turn to you, our audience, to engage in this crucial dialogue. What are your thoughts on the future of green hydrogen and electrolyzer technology? How do you see these advancements impacting our energy systems and climate goals? Are there specific challenges or opportunities you believe need more attention? We invite you to share your insights, questions, and perspectives in the comments. Your input is valuable in fostering a deeper understanding and discussion about green hydrogen's role in our collective energy future. Let's continue this conversation and contribute to the momentum towards a more sustainable and energy-secure world. Together, we can navigate the complexities of this evolving landscape and contribute to a cleaner, more sustainable future powered by green hydrogen and innovative technologies. Thank you for choosing RenewEnergy.com as your go-to source for all things renewable energy and sustainability. With our YouTube channel, we explore the latest developments and innovations in the field, including hydrogen fuel cells and the use of AI and machine learning to optimize energy consumption. If you're ready to take the next step towards a cleaner, more sustainable future, visit us at RenewEnergy.com and discover the many ways we can help you transition to renewable energy. Thank you for watching and subscribing. Stay up to date on all the latest news and insights by subscribing today.